Okay, good morning. So I will not be joining you today, but we are starting day one of an exciting unit called conics. And so conics is basically, we are going to be graphing circles, ellipses, parabolas, and hyperbolas. And so we're going to talk about how to classify a conic, meaning how do you know what you're going to graph, and how they're formed. And then in this video, we will talk a little bit about just how to graph circles in standard form. So the first thing you want to know is, how is a conic formed? So one of the things you can do if you have, this is sometimes called a double-naped cone. So what I like to picture is kind of two ice cream cones that you kind of put end to end. And then they're saying, if you took that and you took a really sharp sword or something, and then you cut it, so there's this thing, if you kind of went straight through it like that, and then you picked this piece up and turned it, what would that shape be? So if you did that, that would form a circle. Kind of that cross section there would end up being a circle. Now, if that sheet of paper, if you didn't go straight across, what if you went it at an angle? I know it's a little bit hard to see there, but you can kind of see here, if that sheet of paper sliced it at an angle, if you looked at the cross section there, you'd end up with an ellipse or an oval kind of shape there. And then if you took that sheet of paper and you went from the bottom of the cone and out the side, well, then you'd be left with a parabola. And then if you took that index card and you kind of chopped it straight down, you'd end up with two parabolas, also known as a hyperbola there. It'd kind of be two parabolic looking shapes there, which would be a hyperbola. So how are you going to identify which pieces are what? In your ring of knowledge, so I got to flip this, and I'm going to affectionately call your ring of knowledge your rock, there is a way that you can kind of classify conics. So you've got this kind of salmon colored sheet of paper here, and you can take some time today and you can kind of cut it up. And what I did is I punched a hole in it in the upper corner, because then once you punch a hole in it, I can give you, a paper clip or something, and you can kind of have it like this. Or for those of you that prefer, you could just do index card. You could kind of treat it like index cards. But I'm calling it your ring of knowledge or your conic rock. Okay. So on one of the cards from your conic rock, you'll see this kind of flow diagram. Now, this is going to be important because it's going to help you classify the conics. And I know it's kind of hard on here, but you have it in front of you that you can kind of read and follow along. Let me see if I can zoom in. Okay, so there we go. So conic sections. The first thing you want to ask yourself, are there two squared terms? Is there an x squared and a y squared? Because what we're trying to do is answer the questions from your notes, which would be, given something that looks like this, we're trying to figure out what type of conic is it. So the first thing you want to do is ask yourself, are there two squared terms? Okay? And then, if the answer is yes, then you have to go on and ask yourself the next question. If there's not two squared terms, meaning there's only one squared term, then you know that it's a parabola. So this is kind of like, if you say yes, then you need to ask yourself the next question. So the next question is, do x squared and y squared have the same sign? Meaning, are they both positive, or is one of them negative? Are they both positives? Are they both negatives? Do they have the same sign? If no, if one of them is positive and one is negative, then you're looking at a hyperbola. Okay? If the answer is yes, if they are both two positive squared terms, then you have to go and ask yourself the final question. So, do the coefficients, do they have the same coefficients? Do they have equal coefficients? If no, then it's an ellipse, and if yes, then you have a circle. So using that flow diagram, we're going to go ahead and start our notes, and we've got this here. So I might need to zoom out just once. Okay. So it says, using your rock, your ring of knowledge, identify the type of each of the following conics. So here, I'm going to, be using that diagram. So it says, are x squared and y squared present? So here I have an x squared and a y squared. So my answer there is yes. So then I'd have to go down my flow diagram with yes. So if the answer is yes, I have to ask myself the next question. So do x squared and y squared have the same sign? Well, here the x squared is positive, but this negative is with the y squared. So my answer there would be no. Well, if there's two squared terms, but one of them is negative, that tells me that it's a hyperbola. So you could put an H there, or you could write out hyperbola, either or. I guess I'll write it. Okay? All right, and then we're going to go on to the next one. So in number 2, are there two squared terms? Well, I've got an x squared, right? If I FOILed that out, I'd end up with an x squared. But I don't have a y squared. Well, that means that it's a parabola. Okay, so if there's only one squared term, it doesn't matter if it's x or y, it's going to be a parabola. Okay, we'll talk about what that means in a couple days. And then here, you have an x squared and a y squared, right? If you FOILed those out, you'd have x squareds and y squareds. So I have an x squared and a y squared. They're both positive, right? This is a positive here, there's a positive, so yes, they're both positive. So then I have to go to the third and final question, which says, do they have the same sign? So are they both, or I'm sorry, the same coefficient. I misspoke there, I meant to say coefficient. So do they have the same coefficient? Well, if you FOILed this out, you'd end up with an x squared divided by 4. So in other words, the coefficient would be 1/4. And then if I kind of FOILed that out, I'd have a y squared divided by 1, so the coefficient would be 1. Well, 1/4 and 1 are not equal coefficients, so then we would say this is an ellipse. Okay? So an ellipse for that one. And then finally, here you have two squared terms. They are both positive, and the coefficients are the same. This would be a 1/49th, and that would be a coefficient of 1/49th. So that would tell me that this one is a circle. Okay? So if you can go ahead and go back to your rock and find this page here that says identify the conics below. So take a moment and see if you can go ahead and identify them. So kind of use your chart and see if you can identify those conics. You can pause the video if you'd like. Okay, so I'm going to assume that you went ahead and paused the video. So hopefully here you said, all right, there's two squared terms. They're both positive, but the coefficients are not the same. Okay, the coefficients are not the same, so that means that it's an ellipse. Okay, here, notice I'm not paying any attention to the other stuff. I'm really only looking at those squared terms. All this other stuff I'm not paying attention to. So here, there's two squared terms, but one of them is negative. Okay, so again, you're kind of using that flow diagram. So there's two squared terms, but one is negative, so that tells you it's going to be a hyperbola. In this one, I think there was a typo. I think we wanted this to be a plus sign there, so go ahead and fix that. That was a mistake. Apologies for that. So if you've got this, there's there's not two squared terms. There's only one squared term, so that tells you it's a parabola. And again, sorry about that typo. And then here there's two squared terms. They're both positive, and the coefficients are the same. So that means that it is a circle. And then here, there are two squared terms. One of them is negative, so that means it's going to be a hyperbola. Okay? So notice they can have, this is like a general equation, or you could have more of what we call standard equations. Today we're going to focus on circles, and we're going to look at them in standard form, right? That means that they're all ready to be graphed. Or we can look at them in their general form. That's when they kind of look more like this. And those we're going to have to do some extra work to get them into the form in order to be able to graph them. Okay, so the first thing we're going to take a look at today is the circle. So just a reminder that our circle has two positive squared terms with the same coefficients. So the coefficients are equal. And the key parts to a circle are its center and its radius. So the standard form, this is the form that's easier to graph in, okay, is when it looks like this. And you're like, that kind of looks scary, but it's really not too bad. Basically, the center is the opposite of this number for the x value and the opposite of that number for the, for the x value and the y value. So your the center of it is going to be at h, k. That should kind of go in line with what you learned from your transformations from Algebra 2, because remember, it's always the opposite of what you think when it's in the parentheses. And to figure out your radius here, you have to take the square root of whatever this number is, because that is r squared. So to get the radius, you have to take the square root of that number. So it's a little easier with numbers. When you take a look at this one, this would be a circle. Again, there's two positive squared terms. The coefficients would be equal, because if you FOILed that out, you'd end up with just an x squared and a y squared, so the coefficient would be 1. And here, this circle would be centered at 4, negative 3. And then it would have a radius of 9. So if you wanted to graph this, you would go to positive 4, negative 3, and you'd put a dot. And then you would count 9 to the left, 9 to the right, 9 up, and 9 down, and then you'd be able to graph the circle. Okay, so that's what's on your ring of knowledge, and that's just kind of a reminder. So then we'll kind of flip over to the other page. Okay, so this is back to your notes page. So again, just a reminder where it kind of gives you that standard form of the circle, and it reminds you that your center is at HK and that you have to take the square root of that number to get your radius. Any diameter of the circle is a line of symmetry. That's going to be important. Star that because that's going to be a test question. So you need to know that anything that, kind of cuts the circle in half is going to be a symmetry. Okay. Now, notice these are all set up and ready to graph. Again, these are all circles because it's only the first day, and I'm kind of letting you know it's a circle by asking you for the center and the radius. But keep in mind that, in a few days, you're just going to be given this, and you're going to have to go through those questions and be able to determine what the conic is first and then sketch it. But we know this is a circle, so my center, again, you do the opposite of what's in there, the opposite of what's in there. So my center is going to be at -2, 3. And then I take the square root of that number to get the radius. So my radius is 4. So if I was graphing this, I'd go -2, +3. There's my center. And then the radius is 4. So I'm going to go 4 up, 4 to the left, 4 down, and 4 to the right. And then you can kind of sketch in a circle. Now, although I'm not going to be very judgy, your circle should not have sharp corners. I shouldn't be able to pop a balloon on there. I know it's not going to be a perfect circle, but just do your best to sketch it in there. Okay, so yeah, you've got a circle there. Now, other questions they might ask you on the test, they might say something like, which of the following points lies on the circle? Well, you could sketch it out and then kind of see, like it kind of looks like that point might be on there. But if you are ever asked that, and I'm just telling you this because it is a test question, if you are ever asked to determine if a point lies on the circle, if you plug in the coordinates of any x and y value, it should make the equation true. If you plug in the coordinates and it does not make the equation true, then it does not lie on the circle. Okay. All right, let's graph this one now. And again, we're going to do the opposite. So we're going to have a center at 4, 5. And keep in mind, sometimes to be tricky, what they'll do is they'll put the y thing first and then the x one behind it just to try to be tricky. So don't let that fool you. Remember, the x coordinate from your center always comes from the x, whatever number is with the x, well, the opposite of it, the number with the x. And again, we take the square root of that 25 to give us a 5. So if I was graphing this, I would go to 1, 2, 3, 4, and up 5, put a point there, and then I count 5 to the left and 5 to the right. Oops, I have to right then left. And then 1, 2, 3, 4, 5, and there. And again, we're just going to kind of sketch in the circle. It doesn't need to be perfect, but hopefully it looks circle-ish. Okay, so we've got that one. All right, moving on to number 3. So this one's a little trickier because you're like, oh, there's no number with it. Well, another way you could think of that then is x plus 0 quantity squared. So basically that just means, your center is going to be on the y-axis there. So my center is going to be 0, -6. In my radius, the square root of 1 is still 1. So this is going to be a little baby circle. So 0, -6, there's my center. And then with a radius of 1, guys, it's going to be like the most puny, pathetic little circle. It looks like a little eyeball. Keeping an eye on you. Okay? So we've got that. All right, so now what I'd like you to do is pause the video and go ahead and find the circle. There should be circle equations here. Okay, so these are both circles. So go ahead, pause the video, and try to graph this one on there. And we'll work on example 2 in just a minute. I will go back and go over this after I teach you how to complete the square. But you can kind of pause the video and try to graph that one. Okay, so I'm assuming you went ahead and paused the video. So in order to graph this one, you should have gone -2 and a +5 right up there. And then a radius of 4, so 2, 4, 2, 4, 2, 4, and 2, 4. Perfect. So then you can graph this one right there. So again, the center on there was a -2, 5, and the radius was 4. All right. So then go ahead and pull back out your notes, and we're going to go ahead and write the equation when you were actually given the graph.